Hello, this is Mrs. Spellman. Welcome to GCSE Computer Science. Let's get started. So today we're working on memory and storage, which is a red topic. And it's a very large topic, numbers. So I've split it into smaller videos. So I would just like you to see where your knowledge is right now on this bullet point. So you might want to pause the video and do that. And fill in this ticket in your green book when you're done. I'm introducing a new number system to you today, base 16. So you're already familiar with base 2 and base 10. Base 2 has got 2 digits, 0 and 1. And base 10 has got 10 digits, 0 all the way to 9. Now hexadecimal has got 16 digits. So we're going to count in hexadecimal to see how that works. And we're going to keep the denary and binary beside us so we can compare. So 1, 2. Now when we look at 2, in binary that is 1, 0. And in denary and hexadecimal it's the same, it's 2. 3, 4, 5, 6, 7, 8, 9. Now when we get to 9, the next number is going to be denary 10. So with denary, that's reached its maximum digit, so it now needs to go to the next column. So there's going to be a 1 there for 10, so it'll be a 1, 0. However, hexadecimal hasn't reached its largest digit yet, so we need to see what will it do. So what it does, it starts using letters. So 10 is an A, and then 11 is a B, C, D, E, F, and it finishes at F. And it finishes at 15. And if we notice, when this bit here is at its highest digit, the nibble is also full. So a nibble that's of the value 15 is full, and one bit in hexadecimal with the value 15 is also full. It's a nice link between the two number systems, and it's something that makes it really easy to convert from one to the other. So that is a reason why computer scientists use hexadecimal. And the other reason is because it's a lot easier to read than binary. It's shorter. Okay. So 15 then is 0F. So when we get to 16, we're just going to put a 1 in the 16s column and a 0 in the 1s column. So that is our 16. Now, could you have a go at converting what we call hexadecimal A to denary? And I'm sure you got 10 because A represents 10, and that just means 10 times 1. What about 1A? Okay, so the A represents 10, so it's 10 times 1. The 1 means 1 times 16, so we have 16 plus 10, and it's 26. And now have a go at converting 2. Okay, and you would have said 2 times 16 plus 2 times 1 equals 34. So 32 plus 2 is 34. And you'll have shown your working. And of course, it's important in the exam to show your working. Now, if you were working through this and you said 16 plus 2 is 18, when you times that by 2, you would get 36, which is wrong. So it's very important to follow the BIDMAS rules. And what I do to make it easier for myself and for other people to read is I just put brackets around this to know that has to be done first. I mean, we know multiplication happens before addition in BIDMAS. However, it's good practice in computer science, actually, to put brackets around whatever needs to be done first. Okay, so again, if you have a go at this one, remember you're not allowed to use a calculator, and I'm about to reveal the answer. So 4 times 16 is a bit more difficult. Have you got a strategy for timesing 4 by 16? You might just do that as timesing it out, writing down a small multiplication sum, or you might say 16 times 2 is 32, and times 2 again is 64, then plus 2 is 66. Whatever way you do it, you must remember you won't have a calculator. Okay, so they're getting a bit more difficult, and for that reason, I have put the 16 times table here for you, and I have put the denary to hex conversion here. So if we are going to approach this, we would have to find 5 times 16 over here, and that is 80. And then over here, we would have to find C, and that is 12. So 80 plus 12 is 92. So I hope you got that. And now if you have a go at this one. Okay, so you went over here to find out that F is 15. So that is 15 times 16, which is 240, plus another 15, which makes it 255. Now, in the exam, you might get overwhelmed if you need to work out something like 16 times 15. And there's lots of different ways you could go about this. You could know your 16 times table. You could just put the two down together and do your multiplication. Or you could go to one that you know, like 16 times 10, and then just keep adding 16 until you get to what you need. So find a strategy now in advance that you will use in the exam. Now we have this number 255. We've come across this before, if you remember. A byte when it is full, so 8 bits, all having a 1 in them, is the denary equivalent of 255. And here we are now when we've got 2 hexadecimal bits full. It is the denary equivalent of 255. So yet again, a lovely example of the pattern between binary and hexadecimal. Okay, could you work out how to represent 36 denary in hexadecimal? Okay, let's have a look at that. So you probably saw straight away that that's very close to 32, which is a multiple of 16. So you probably put 2 in there because 2 16s are 32. And then you probably subtracted the 32 from 36 and you got 4. And that's exactly the method you should be using. So dividing our number by 16, seeing how many times it goes fully into the number, and then looking at the remainder. And our 2 went there and our 4 went there. So let's try another one. So 175 this time. So looking over here, how many times will 16 go fully into 175? And I can see that it will go 10 times fully. And that would be 160. And then there is another 15 to get to 175. So 175 divided by 16 is 10, remainder 15. So in order to have a 10, we use an A, so we put an A in there. And for a 15, we use an F, so we put an F in there. Another one for you to have a go at, so pause the video if you need to. Okay, so how did you do? We divide 126 by 16, it gives us 7, remainder 14. So we put this 7 under the 16s, and we put the 14 as an E underneath the 1. Okay, so what have we learned in this video? We've learned that hexadecimal is a number system with 16 digits. And when we run out of numbers, we start using letters. So here we can see that A is 10 and B is 11 and so on. Pause the video to take stock of where you feel you are now with this topic. and fill in the ticket in your green book. I hope you've made progress and I hope you've enjoyed learning hexadecimal. But that's it for now.